Good morning, good afternoon, whatever it is for you. This is section 8.2 for statistics, math 1040. And it's kind of an extension of what we did in 8.1. So it definitely refers to this idea of a distribution. We'll talk about that in just a second. So to start off, I want to talk about the difference between a proportion and a mean. So a mean is an average, right? Like you take, you add up a couple of numbers, or your grade point average or whatever. You add up numbers, divide by the number that they are, right? So if I had 4, 7, and 9, the average would be 4 plus 7 plus 9, which is 20, and then divide that by 3, and I would get whatever I get, right? 6 point something. So this is a mean. Now, what's a proportion? It's not difficult what a proportion is, but it's important to start thinking about how these two are different so that you can orient your brain to what the question is asking. So proportion has to do with this something out of something, right? So if I said something out of something, like how many purple Skittles were in this bag that I opened up? Oh, well, there were 4 out of 11. So a proportion has to do with the fraction out of the total. It's very similar to thinking about probabilities, but if I did something easier, let's say 4 out of 10, then the proportion would be 0.4. So a proportion is always going to be a number between 0 and 1 when you convert it to a decimal, okay? All right, let's talk about a population, which, remember, is like the biggest group, if I'm talking about the population of Americans in the US. The mean for a population would use this Greek symbol for mean. If I had a sample out of that population, I would use X bar for mean. For proportion, I would use a P, and then for the sample, I would use a P hat. So I don't want you to get all freaked out about this symbol of P hat. P hat just means it's a proportion of a sample. Okay, so how do I find P hat? P hat would simply be the number of purple Skittles out of the total number in the bag, right? So this is the number that have that characteristic divided by n is your sample size. Okay, so mean you're very familiar with, you're just taking an average. You're actually pretty familiar with proportion. 5 out of 6 dentists recommend such and such, right? We talk about proportions all the time, but we don't think about this P hat as denoting the proportion of a sample. And we don't necessarily think about this formula, even though it's a very self-explanatory, somewhat intuitive formula. It's however many have it out of the total, okay? So why am I bringing this up? Because in 8.2, we talk about these proportions in a similar vein as what we talked about the means in 8.1. So let's see. So we're talking about, in this case, a sampling proportion. Now, remember that for the sampling mean, what that meant was, I gave the example of 10 people in the class. I wanted to find, I could figure out the average of all 10 people. That would be the population mean, right? But then I could take groups of 3, sample sizes of 3, as many groups of 3 as I could. And if I found the mean of each of those groups of 3 and then took all of those means and averaged them, that would be a sampling mean. So in this case, we're talking about a sampling proportion. So you take a sample size out of the bigger size, find its proportion. Should it be the same as the original proportion? No, because like if I wanted to say, let's say my proportion would be all senators, and I wanted to know how many had children. And let's say out of 100 senators, 74 had children. So 74 out of 100 would be my proportion for the population. But then let's say I took a sample, and let's suppose my sample size was a group of 10 of them. And out of the 10, maybe 4 of those 10 only had children. So then the proportion for that sample would be 0.4. 0.4 was a proportion of senators who had children out of a sample size of 10. Now, if I took every sample of 10 senators, which remember there were a huge amount of those, so you could go 10C100 to figure out how many ways I could take 10 people out of the 100. And for each of those samples, I figured out the proportion of the number of people who had children out of that sample. And then I took all of those proportions and I averaged them. So now we're going from proportion and throwing a mean in there. I averaged all the proportions, then that would be a sampling proportion. So that's a lot to hold on to in your brain. You don't necessarily have to think about that every single time you do a question, but I just wanted to orient you as to what a sampling proportion meant. Okay, and then that brings us to this formula. The mean of the sampling proportion, because remember we would average every one of the proportions that we found for all iterations of 10 senators, right? If I took the mean of that sampling proportion, then it is P, it is the proportion of the original population. Okay, so why is this important? Well, we're going to use this in figuring out a lot of the questions. So let me pull up the notes, and we've got 2 basic formulas that we're dealing with. So how would I talk about that mean? The mean of the sample proportion looks like this. So yes, that looks funky, but you know what these symbols are. This is the mean for the population, in this case, of the sample proportion, right? And that equals P, which is the proportion of the original population. Now, what else are we going to find? The standard deviation of the sampling proportion. And this is a little more involved formula. It's not too bad, but it's not like super easy. P times 1 minus P over N. And then we take the square root of that. Okay. So these are the 2 main formulas for this section. We had 2 formulas for 8.1. The first one was easy, just like this one is. The second one was a little more involved. And so let me talk about what you're going to do on these problems. So the structure of the questions are going to feel similar to what we did on 8.1. What did we do on 8.1? Well, we first had to check that it was normal, right? And for this section, that check is a little bit different. So the question is it normal? Now, how do we check that in 8.1? Well, either it came from a population that was normal, or our sample size was greater than or equal to 30. How about for this one? For this one, there are also 2 checks. The first check is little n is less than or equal to 0.05 times big N. And then the second one is n times p is times 1 minus p is greater than or equal to 10. So you're going to use these 2 formulas to verify that it's normal. Why do we want to verify that it's normal? So that we could then use our normal calculator. They'll have us figure out the proportion, or the mean and the standard deviation of the sampling proportion. Then what will we do? We'll plug the mean and standard deviation into our normal calculator on StatCrunch. How do we get to that? Stat calculator, excuse me, normal. Remember, the mean is here, so you'll plug your mean in, standard deviation, and then you have the x greater than or equal to, less than or equal to, and then here you have the probability, right? So what'll happen is you'll look at a question, you'll verify that it's normal, Then you'll calculate the mean and standard deviation using these two formulas. And then you'll open up your calculator. You'll put in your mean and standard deviation. Usually they're going to ask you a question and you'll type your number in here and then you'll give them the the probability, because they'll be asking a question of probability. I think there's one question where they ask the probability and you have to give them the X value. Okay, so let's go through two problems. So I'm looking at problem number 4. And on problem 4, we're not actually going to go all the way to the calculator. They just want us to do the checks and then do the mean and standard deviation. So mine says describe the sampling distribution of p hat. Assume the size of the population is 15,000. So this little n is my sample size. The big N is my population size. So they tell me that my population size is 15,000. And then they tell me that my sample size is 700. And my P, my proportion, is 0.3. So how would I verify this? Well, I would run them through both of these formulas. So little n, which is 700, has to be less than or equal to 0.05 times big N, which is 15,000. So what I would do is multiply 0.05 times 15,000 to prove that 700 is less than whatever that answer is. I don't have my calculator on me, but you can try that, and I've already verified that it is. So 700 is less than whatever that answer is. Okay, second part. This is a little n, so I'm going to go 700 times p, which is 0.3, times 1 minus 0.3 is greater than or equal to 10. So again, you're going to punch this into your calculator. 1 minus 0.3 is 0.7. 0.3 times 0.7 is 0.21. And if you multiply 0.21 times 700, you will get a number that is greater than or equal to 10. So it checks out. They're both normal. Both of those tell you that it is normal. And now they want us to determine the mean of the sampling distribution of p hat and then the standard deviation of the sampling distribution of p hat. So how do I find the mean? The mean of p hat equals p, which was 0.3. So there's no calculation to do there. You're just going to grab what that original p was. So that formula is easy. How about this one? How about the standard deviation of the sampling proportion? Well, it's going to be 0.3 times 1 minus 0.3 all over 700, and that whole thing gets square rooted. When you crunch that down in your calculator, you should get 0.017. Okay, so that's all that you have to do on question 4. And question 5 is the same type of thing. So questions 4 and 5 haven't yet gotten you to your normal calculator. All right, so then we jump into question 6, and that's a full question. It's going to have us do all of the above. So we start off, they give you your little n, they give you the big N, they give you a p, and you start off by doing the normal checks. And if that checks out, then you're going to jump down and you're going to do your mean and your standard deviation. And then they're going to ask you a question. So mine says, what is the probability of obtaining x equals 36 for more individuals with the characteristic? That is, what is, and they give us this probability. So let me erase this right here. So they say, what is the probability? So remember, when we have a p in front of that parentheses, they're asking for the probability that p hat is greater than or equal to 0.48. Now, they can't ask you a question that doesn't allow you to put it in as a probability. Remember, a proportion. Remember, a proportion is always from 0 to 1 because it's a part of a whole. And I'll talk about that in a second with question 7. I think it's 7. So here they say, what's the probability that p hat is greater than or equal to 0.48? So what you would do is you would put in your mean. So for for my new problem, not that one, my new problem, my mean ended up being 0.4. My standard deviation was 0.056569. And they're asking me a question about the sampling proportion being greater than or equal to 0.48. So greater than or equal to 0.48 goes here, and then this is where my answer will be, okay? But notice, anything I put in here, if it's a proportion, has to be between 0 and 1. Proportions are always between 0 and 1. And I'm driving this point home, not for problem 6. Problem 6 is pretty straightforward, but because in problem 7 and 8, I believe, you've got to do a little finagling. So I'm in problem 7 now. So let me erase this. And this is the point I want to make in 7. So they start off, they want us to do our normal checks. No, actually they don't. They tell us that it's normal. And then they have us figure out the mean of the sampling proportion, which mine was 0.54, and then the standard deviation of the sampling proportion, which mine was 0.0158. Okay, and then they jump right into the probability. They say, what is the probability that obtaining X is greater than or equal to 570? So this is the part I want to point out. I can't put 570 into a proportion flavored calculator, okay? Here's 0.54, here's 0.0158. They didn't give me a proportion, in fact. So why do I need a proportion? Because these are all proportions. They didn't give me a proportion, they gave me 570. But they also told me that n was 1,000. So remember, a proportion, the p hat, is x over n. So I'm going to go 570 out of 1,000. They just asked me a question about being greater than or equal to 570 people. But this is all in terms of proportions. So 570 out of 1,000 creates the proportion. So that's what gives me the number between 0 and 1 down here. And once you're able to train your eye to say, hey, did they already give me that as a proportion? Which they did in question 6. They converted it for you, but they did not in question 7. So once you're able to recognize that, then you can make that conversion by doing the x over n, making sure that this number that you put in here is between 0 and 1. If you didn't, think about it. If my mean is 0.54, like that's a little tiny number. My standard deviation is just barely moving by 0.01-ish, right? And I'm asking a question about if I had plugged in 570, which would be off the charts, then you would expect to have nothing bigger than 570, right? This would be all white if you made the mistake of not putting your proportion in. Okay, let's look at question number 8 real quick. Same type of thing. So they start off, well, here they kind of ask you a couple questions first. And then question 8 is a little weird because they want you to verify these two things in a story format. So look at the homework help. I've printed off mine, and you're really doing the same thing. You're just putting it into this paragraph. And then they get down to D, where they say, in the sample obtained in part A, what is the probability that the proportion who are satisfied with the way things are going in their life exceeds 0.77? So that's not a big deal, right? So that's the probability that the proportion exceeds 0.77. They've already given it to you as a decimal, so you would just stick that in there. And then part E, they say, use the distribution from part C. Would it be unusual for a survey of 100 people to reveal that 67 or fewer? So notice that they've changed the way they said it. In a survey of 100 people, 67 or fewer. Well, you're not going to do less than or equal to 67. You're going to do less than or equal to 67 over 100. You've got to put it into the proportion form. So that would end up being 0.67. Okay. And I think that if I don't point this out, then what happens is you think you understand what's going on, and then you just get thrown with these problems, and then you start second guessing your knowledge. But it's not about that. It's about them just being a little bit tricky. Okay, so what's going on in problem 9? In problem 9, they choose a third way of describing it. They decide to use percentages. So they say something like, you know, what's the probability that in a random sample of 300 adults, more than 35% do not own a credit card? Well, that's not difficult. It's actually easier than this. But if I say more than, the probability of greater than 35%, of course I can't put 35% in. I would convert that to 0.35. So that's not too bad, but I still want you to be able to recognize that that's now a third method. So they either gave you the proportion, or they gave you the amount and the sample size so that you can turn it into a proportion, or they gave you a percent, which you can then turn into a decimal, which is a proportion. Okay, and then problem 10 is a completely different way of going about this piece. So they're focusing on this formula, and it's a completely different way of asking the question. They don't do any of the other stuff. I would recommend that you work through the homework help, and I describe exactly how to answer that question. Feel free to let me know if you are struggling with it. And then 11 is just asking you some of the concepts, and I don't think they're too bad once you've gotten through the rest of the homework. All right, and that wraps it up for chapter 8. I'll talk to you later.